It's your friendly math tutor, Miss C, here to solve a quadratic equation. As a reminder, there are two ways that you can solve quadratic equations when they're written in general form: factoring or using the quadratic formula. Today, we are going to use the quadratic formula. And in case you can't remember what it is, I've written it here to the side. So our first task is to label each of the terms A, B, and C, and this matches the variables we use in general form. So this purple term is term A, this yellow term is term B, and this white term is term C. And we are going to be substituting those terms everywhere we see A, B, and C in the quadratic formula. Now, just one big thing to point out: the signs or the operations in front of each term come with them. So A is negative 1/3, B is 2/3, and C is 21. So the big mistake people make is they oftentimes will drop the negative signs when they do this, and we just want to be careful not to do that. All right, here we go. So I'm going to go ahead and substitute x equals negative b. So I'm going to put a negative sign, and I'm going to substitute 2/3 in here. Okay. Plus or minus the square root of b squared. And again, in here goes our 2/3 because we're using the b term, minus 4 and a, which is negative 1/3, and c, which is positive 21, all divided by 2 times a, which was negative 1/3. So as a quick check, you could see that we've plugged b in twice, we've plugged a in twice, and we've only plugged c in once. So we've substituted correctly. And now we're going to go ahead and simplify. So x equals negative 2/3 is negative 2/3, plus or minus the square root of, we have 2/3 squared. If you remember having a fraction raised to a power, you square both the numerator and the denominator. So 2/3 squared is 4/9 minus, okay, I'm noticing I've got a negative 4 times a negative 1/3 times a positive 21. I've got two negatives multiplied. It's going to turn this to a positive. So here's how I like to think through when I have fractions. I may be one of the rare people who loves fractions. I know that 21 is 21, 3 goes into 21. So if I say 21 times a third, that's like saying 21 divided by 3. I know that's 7, and then 7 times 4 is 28, all divided by, and we're going to do the same thing here. There's a hidden 1 underneath that 2. We multiply numerator to numerator, so negative 2/3 here. Okay, and then we're going to come down and we are going to simplify this even further. Negative 2/3 plus or minus the square root of 4/9. Okay, so at this point, I need to get a common denominator so that I can combine these two terms. So since 4 already has 9 in the denominator, I'm going to multiply 28 over 1 by 9 over 9. I'm making an equivalent fraction here, so I'm just going to do this really quick. I get 72. So that's 252 over 9, right? All divided by negative 2/3. I'm going to erase over here to give myself a little more room. Fractions can be annoying, especially if they're not your thing, but they are actually pretty prevalent in the real world, so it's always good to practice with them. So over here, I end up with x equals negative 2/3 plus or minus the square root of, so when we add fractions and we have a common denominator, the common denominator stays the same and we add the numerator. 4 plus 252 is 256 over 9, all divided by negative 2/3. Okay, all right, and now we're going to simplify even farther. So we have negative 2/3 plus or minus. Okay, so we are going to, I wrote the square root and I did not mean to. We are going to take the square root of individually the numerator and the denominator, because that's how square roots work, because a square root is really the exponent of half. So when it's applied to a whole fraction, you apply it to both the numerator and denominator. So the square root of 256 is 16. and the square root of 9 is 3. And all of this gets divided by negative 2/3. All right, so at this point, we need to start combining our like terms. So I've run out of room, so I'm going to create a little more space here by erasing some of our work on this left side. Normally, if I were doing this on paper, I'd have all of my work, so if I made a mistake, I could go back. But I have limited space, so here we go. So I'm going to do the addition first, because really the plus or minus means there's two separate equations that we've condensed into one, right? All divided by negative 2/3. So again, we're adding and subtracting fractions in the numerator. So we keep the denominator, which is 3. So we have negative 2 plus 16, which is positive 14, all divided by negative 2/3. The way that I like to deal with fractions is I like to multiply by their reciprocals. So I'm making 1 in the denominator. What I do to the denominator, I do to the numerator, because I'm essentially making an equivalent fraction. This makes a 1, it goes away. The 3's cancel out. And then I end up with x equals, I've still got a negative hanging out right here. So 14 divided by 2, which is negative 7. All right, and now we're going to do the same thing for the negative side. So x equals negative 2/3 minus 16/3, all divided by negative 2/3. When I do that, I get negative 2 minus 16, which is negative 18, over 3, divided by negative 2/3. So I'm going to make this easy on myself. I know that there's two negatives. Two negatives make a positive, so I know this solution is going to be positive. And then I'm going to multiply the denominator by, I'll switch colors here, by 3 over 2. It's reciprocal. And if I do that to the denominator, I'm doing it to the numerator. That makes a 1 here. So the 3's cross cancel out. And then I have 18 divided by 2, which is 9. So if I wanted to check my work, I would plug both of these x values into the x's and make sure when I do that, I get 0. I know these are the right answers because I wrote the problem, so I'm not going to work through that. But this is how you use the quadratic formula to solve a quadratic problem. Make sure to subscribe for more math videos. Till next time, you've got this.